They installed the ridge vent on a Thursday. By Saturday, the attic was hitting 160 degrees Fahrenheit. The installer stood at the peak of the roof, pointed at the vent running the full length of the ridge, and said, "It is working perfectly." He was right. That is the part nobody tells you. The vent was not broken. It was not clogged. It was not undersized for the roof. It was doing exactly what a ridge vent does when you give it no help from below. It was sitting there, sealed by the laws of pressure, moving almost no air at all, while the wood above your bedroom slowly cooked. That is the problem this video is about, not the vent at the top, the 20 feet of dead space below it. Think about what your attic does in July. The sun hits asphalt shingles that are already dark, already designed to absorb heat, and it drives that surface temperature past 150 degrees Fahrenheit, according to measurements published by the Oak Ridge National Laboratory. The deck beneath the shingles heats by conduction. The air inside the attic heats by radiation and convection together. Within 2 hours of sunrise on a clear summer day, that space becomes an oven. The ceiling between the oven and your living room is roughly 3.5 inches of fiberglass batting and drywall. That is your only shield. Now, think about what sits directly under that shield. The air your air conditioning system just spent money to cool. The heat does not stop at the ceiling because it is polite. It moves toward every cooler surface it can find, and the ceiling is one of them. The Building Science Corporation, in research published on their public technical library, documents this relationship clearly. For every 10 degrees Fahrenheit the attic exceeds the conditioned space, you add measurable and compounding load to your cooling system. The numbers are not abstract. They show up on your bill every month from June through September. But the cost does not stop at electricity. The shingles are paying for it too. Asphalt shingles are rated for temperature, but that rating assumes ventilated attic conditions beneath them. When ventilation fails, the deck temperature climbs, and the underside of the shingle absorbs heat from below while the sun attacks from above. Gaff, Owens Corning, and CertainTeed each publish warranty language that ties shingle coverage to meeting the ventilation requirements of the applicable building code. The reason that condition exists is documented in the failure patterns manufacturers have cataloged. Elevated deck temperatures cause shingle oil migration toward the surface, accelerate granule loosening, and produce brittleness at corner points and tab edges years ahead of the product's rated service life. A 25-year shingle in a poorly ventilated attic is routinely replaced at 14 or 15 years. That is not a minor footnote. That is replacing your roof a decade ahead of schedule because of a ventilation problem that costs almost nothing to fix correctly. So, you call the roofer back. You explain that the attic is still hitting those temperatures even with the ridge vent installed. And here is the moment where the wrong diagnosis happens almost every time. The roofer looks at the ridge vent. He checks the installation. He checks the manufacturer's spec. Everything matches. His conclusion, and it is a reasonable one given what he is looking at, is that the vent is undersized, or that you need a powered attic fan to supplement it. He recommends adding more exhaust. He may even recommend a second ridge vent. He means well. He is wrong. Here is why. A ridge vent is an exhaust device. It is designed to let hot air out at the peak of the roof, where buoyancy and wind pressure drive air upward and outward. That process works exactly as described in the physics textbooks. Under one condition, there must be an equal volume of replacement air entering from below. According to International Residential Code, Section R806, the ventilation area should have at least 50% positioned at low openings, such as soffit or eave vents, with the remainder near the ridge. The code does not mandate a 1-to-1 ratio between specific components. When inlet area is matched to exhaust area, air moves. When it is not matched, air does not move, regardless of how well your exhaust is installed. The Building Science Corporation explains the mechanism in plain language on their website. They describe the attic as a pressure vessel. When you add exhaust without inlet, you create a zone of slightly lower pressure at the peak. That lower pressure does not go unfilled. It pulls from whatever path offers the least resistance. And in most American attic builds, the path of least resistance is not a soffit vent. It is the ceiling. Your ceiling has gaps. It always does. The Building Science Corporation refers to this collection of gaps as the ceiling plane's air leakage network, and they note that in a typical unretrofitted American house, those gaps can add up to the equivalent of a hole several inches across, sitting open to the attic above. Ceiling penetrations, including recessed lights and plumbing chases, are among the most common contributors to this leakage network. So, when your ridge vent creates that zone of low pressure at the peak, the attic does not wait for air to come through the soffits. It pulls conditioned air straight up through your ceiling, air that your compressor and your refrigerant and your electricity bill all work together to bring down to 72 degrees Fahrenheit, is being sucked directly into a 160-degree space and replaced with nothing that helps you. That is the mechanism, and once you see it, you cannot unsee it. Now, here's the second part of the problem, and it is the part that makes this particularly expensive if you leave it alone. When conditioned air migrates upward through ceiling gaps, it carries moisture with it. In summer, indoor air carries more moisture than attic air in many climates. When that moist, conditioned air hits the underside of your roof deck, you create the conditions for condensation and biological growth on a surface that nobody ever sees until the repair bill arrives. The Oak Ridge National Laboratory has published research connecting air leakage through ceiling planes directly to moisture accumulation in attic assemblies in humid and mixed climates. The Building Science Corporation reinforces this finding. Sealing the ceiling plane is the single most important step in attic performance, ahead of adding insulation and ahead of adding ventilation. But there is an even more direct financial consequence that most homeowners never calculate. Your air conditioning system is sized to handle a specific load. When the attic pulls conditioned air upward through ceiling gaps, that air is lost to the attic and ultimately vented outdoors through the ridge vent. Your system then has to replace it. It is not a one-time loss. It is continuous, all day, every cooling season. You are paying to cool air that is being thrown away through the ridge vent you installed to fix the problem. The ridge vent, without inlet and without a sealed ceiling plane, is not solving anything. It is completing the loop that drains your air conditioning straight to the outdoors. That is the contradiction at the center of this whole situation. The ridge vent is working. The ridge vent is the problem. Now, let us find out if your house is doing this. To confirm whether your ridge vent is drawing air through your ceiling instead of through the soffits, run this test on a still morning with windows and doors closed and the air conditioning running for at least 30 minutes. Light a stick of incense and hold it near the ceiling. Penetrations you can reach from below. The trim ring of any recessed light fixture, the perimeter of the attic hatch, and the collar around any plumbing vent or electrical chase that passes through the ceiling. Keep the smoke source within a few inches of each opening. If air is moving from the conditioned space into the attic through that point, the smoke will draw consistently toward the opening rather than drifting sideways. A steady upward pull at a recessed light trim ring, held for 3 or 4 seconds, is not ambient air movement. It is your ridge vent demonstrating exactly where it found the inlet the soffits could not provide. Mark every location where the smoke moves toward the ceiling. That is the repair map. Now, the fix and the order matters. The first thing to do costs nothing beyond materials. It requires 2 tubes of intumescent fire-rated caulk and an afternoon. Seal every ceiling penetration you found in your smoke test. Around every recessed can housing from inside the attic, not from below. Around every wire chase where it enters the attic floor. Around every plumbing vent stack collar. Around the perimeter of the attic hatch with weather stripping. This step alone, done thoroughly, changes the pressure dynamics of the attic and stops the conditioned air from being the default air supply for your exhaust vent. The Building Science Corporation estimates that thorough ceiling air sealing can reduce attic-related cooling load significantly in homes where the ceiling plane has not previously been addressed. This costs you a weekend and the price of materials. The next step, and this one runs roughly $30 per linear foot of soffit or thereabouts depending on your region, is to install proper baffles and verify or add soffit vent net free area to match your ridge vent exhaust area. This is the step that activates the physics the ridge vent was designed to use. International Residential Code Section R806 specifies 1 square foot of net-free ventilation area for every 150 square feet of attic floor space. That area should be split with at least 50% at low inlet openings and the remainder near the ridge when using a balanced passive ventilation configuration. Measure your ridge vent's rated net free area per linear foot. That number appears on the product packaging or the manufacturer's specification sheet, expressed in square inches per linear foot of vent. Multiply it by your ridge length in feet to get the total net free area in square inches. Your soffit net free inlet area must meet or exceed that total, clear and unobstructed, measured the same way. Baffles must run from each soffit to above the insulation line to keep the airway open. Without baffles, blown insulation or batts can block the soffit inlet at the eave and close off the channel the air needs to travel. At the higher end, if your soffit run is inadequate for the geometry of your roof, a contractor can install vented drip edge or over fascia vents that provide inlet area without requiring soffit modification. This work runs in the range of several $100s for a typical residential application. It is worth getting a written quote against a documented calculation of your required net free area, so you are paying for what the code specifies, not for what is easiest to install. Here is what you must not do. Do not add more ridge vent without first adding equivalent inlet area. This is the single most common mistake documented in attic remediation, and the Building Science Corporation addresses it explicitly. Adding exhaust to an inlet-starved system does not increase airflow. It increases the pressure differential across your ceiling plane. It pulls more conditioned air through more ceiling gaps at a higher rate. It makes the problem larger while looking like a solution. The attic may even appear slightly cooler on a given afternoon, not because the ventilation improved, but because more of your air conditioning output is now feeding the attic directly through the ceiling. The ridge vent at the top of your roof is correct. It belongs there. The air it needs to work with is 20 feet below it, trapped behind insulation that was never given a clear path to rise because nobody counted the inlet area on the day the exhaust was installed. That number, the inlet area, is not a detail. It is the whole system. Without it, everything above it is decorative. Your attic temperature is a symptom. The diagnosis is a ratio. The fix is a calculation. And the calculation is already written in the code that governed the construction of your house. Check the inlet. Then let the ridge vent do what it was always capable of doing. The ridge vent did not fail. It was waiting for the other half of the system. Take a look at your soffit line from the ground this week and tell me in the comments. Can you see any vent openings at all, or is the fascia completely solid?